Good morning, good evening, good afternoon, and welcome back to another math lesson. Today we're going to be moving on to lesson 4 of our transformations unit, combining transformations of functions. Okay, so let's get started. So in general form, we have y is equal to f of x, but when we change that so that it's in transformations, we have y is equal to a times f of b multiplied by x minus h plus k. Okay, so that's applying all of the transformations that we've learned. We've done the vertical and horizontal stretches, okay, and we've also now done the vertical and horizontal shifts, okay? So that's now putting them all into one, okay? So this is called mapping notation here, okay? So this is mapping notation. Basically, how is everything going to look? As I misspell it. Okay, so how is everything going to look? So for this is your original function. So this is your original function. Okay. And this is the new function and how the transformations will be applied to it. Okay. So this is the new function. Okay. When graphing a combination of transformations, order is important. So the very first thing you should do is do your stretches and reflections. Best part about them is you can do them in any order. So that's the A and B values. So you can do A and B in any order you want. Okay. Translations. So those are your shifts. That's your movement. They can be done in any order as well. So that's your H and K. Okay. So those can be done in any order. So if you want, you can do your horizontal stretch and reflection first, or your horizontal stretch and reflection first. Okay, so you can do those first, and then same thing can be said for the translations. You can do your vertical translation first or your horizontal translation first. It really doesn't matter. Okay, so if you use mapping notation, you will always end up with the correct order. When describing transformations as related to a parent graph, so that's the parent graph or the original function before it's been moved, the math language is very important, okay? So A corresponds to a vertical stretch about the x-axis by the factor of the absolute value of A, okay? If A is less than 0, the function is also reflected in the x-axis, okay? So even though there could be a negative number with A, your vertical stretch is the factor of A, the absolute value of A. The negative value only tells you that there will be a reflection. B corresponds to a horizontal stretch about the y-axis by a factor of 1 over the absolute value of B. So it follows the same idea as A, except because you're inside the bracket, you got to do its opposite. So if you're multiplying it by a whole number, you got to take the reciprocal of it. Okay. So if B, however, is less than 0, then the function is also reflected in the y-axis. Okay. So again, the absolute value, so the number for A and B tells you what the factor is. Okay. The negative tells you that there will be a reflection. H represents the horizontal translation. Remember, this is always this will always be the opposite sign. So that's why I always say inside the bracket is always opposite. Okay, so for B value, for example, if it's multiplied by a whole number, you're actually going to do the reciprocal of that when you apply it to X. Okay, H. So if it's inside the bracket, because it's inside the bracket, you do the opposite. So if it says to add in the bracket, you're actually going to shift it to the left. Okay. If you are, if it says minus in the bracket, you're actually going to shift it to the right. Okay. And then finally, the last one where K represents a vertical translation. So A and K, you do whatever it says. Okay. B, you'll do the reciprocal of it. And H, you'll do the opposite of what it tells you to do. Okay. A and K, do whatever it tells you to do. So if it stretches, right, or you have to compress it, right, or K, if you move it up or move it down, right, do whatever it tells you to do. B and H, okay, so those ones, you do the opposite of what it tells you to do. So if it multiplies by a whole number, you're actually going to multiply it by its reciprocal. Okay. All right. So that's the most important part. Again, the mapping notation is the most important part. Okay, so this makes it easier for us to actually go ahead and graph it in the order. So we'll, like, for example, we'll graph it in the order of x first. So it'll be x over b plus h, and then a times y plus k. So that's what we will do. We'll do it in forms of x's first, and then we'll do the y's second, okay? So let's go ahead and let's do some examples. Okay, let's try this example, which says we have y is equal to f of, then we have negative 1 over 4 of x plus 1. So again, a good note of thumb is to kind of split everything up so that we can see what we have. Okay, so if it's in terms of a, well, there's nothing in front of the f, so we can say a is going to be 1. B, so how is this going to affect our value? Our b is going to be negative 4, or sorry, negative 1 over 4, which means what we're going to do, so the scale factor, not the scale factor, the horizontal factor, okay, the horizontal stretch factor, there it is, will be the reciprocal of that. So we will stretch it by a factor of 4. So we will reflect, okay, in the y-axis, okay, and then we will, the horizontal stretch factor is 4. That's what our mapping notation will be. H is 0 and k is 1. So we will move the graph up 1. Okay, so mapping notation and how it will work, we'll have x and y. So we're just going to look at all the individual points here. Looks like we have negative 2 and negative 2. Looks like we have negative 1 and negative 4. We have 0 and 2, or sorry, 0 and negative 2. And then finally we have, looks like 2 and negative 1. Okay, so those are all our values. The mapping notation and how it's going to be is we will multiply the values, the x values, by 4, and then we will add 1 to the y. Okay, so we will apply to the x values. So instead of it being at negative 2 now, we're going to take negative 2 and multiply it by negative 4. Okay, so it's going to be at 8. Okay, so this new point will be at 8, and y plus 1 is negative 1. Okay, so we have 8 and negative 1. This next one we have is going to be 4 and, let's see, negative 3. Next one we have will be 0 and negative 1. And then finally, the last one will be negative 8 and 0. Okay, so we're going to recreate this new graph with our parent graph still there. Okay, so we're just going to plot all the points. Okay, so if you want to go ahead and plot all the points, make sure you do so. Okay, so now that we've gone ahead and plotted all the points, we can go ahead and we can now graph it. Again, it's going to be a reflection, right? So it's going to be the opposite of what it should normally look like. I'll go ahead and I'll re-put the points here. But that is how this graph will look using the mapping notation. Okay, so we've gone ahead and we've created, right, we said A, B, H, and K, what values they are. And then we've gone ahead and changed it so that we have it in our mapping notation, and we were able to map out the actual points. Okay, but that is how this particular graph in its combined transformations will look. Okay, moving on to the next example, we have y is equal to negative 1 over 4, okay, f of 2x minus 1. So in this one, we actually have an a value. We have an a value of negative 1 over 4. So this is telling us that it's going to be stretched by 1 over 4 and reflected in the x-axis. We do have a b value. B value is 2, so it'll be stretched by 1 over 2. We have no h, so nothing happens there. So there's no horizontal shift left or right. We have a k value of negative 1, which means it's going to be moved down 1. Okay, so what we'll do now is we'll do the mapping notations. So we have our original x and y. So it looks like we have negative 9 and 7. So again, I'm doing the far left to the far right. Okay, so -9 and 7. Next one we have is -7 and 1, 2, 3, 4. Okay, then we have let's see, we have 1, 2, 3, 4. So we have -4 and 7. And then finally we have -2 and 7. Okay, so when we do the mapping notation, okay, that now becomes, if we were to, this is going to be x over 2, right? So you're going to divide all your x values by 2, and then it'll be, let's see, y. So it's -y over 4 plus 1. Okay, so that's what it's going to be there. Oops, I need to change these all to 8. 8. I think I need to change this too. This is supposed to be 10. Which makes this 8. 8. There we go. Oops. Okay. So now we can go ahead and do that. So this is going to be x over 2. So now we have, it's going to be -5. And so we have 8. So it'll be -8 divided by 4 is -2 plus 1 is -1. Oh, I'm supposed to move down 1. Oh my goodness. That's gonna be -3. Okay. Now I have everything figured out. -8 divided by 2, so that's gonna be -4. Okay. -4 divided by 4 is -1 minus 1, so that's gonna be -2. We have -4 divided by 2 is going to be -2, and then 8 divided by -4. That'll be -2 minus 1 is going to be -3. Oh, so it's going to be the same value as before, -3, and then -2 divided by -1, and -3. Okay. So now we can go ahead and we can plot out these points. So let's plot out these points real quick. Okay, so now that we've gone ahead and plotted these out, we can now graph. So you can see that the graph has been flipped. It looks like it's upside. Our new graph looks like it's upside down. Okay, but that's what's supposed to happen, right? Because we have a reflection of the x-axis, so it looks like it's supposed to be upside down. Okay, but it is the exact same graph. We've gone ahead and we've stretched it by a factor of 1/2. Okay, or you can think of it as we've compressed it by a factor of 2. So it's actually smaller. Okay, but essentially that is what this graph will look like. Okay, so that is y is equal to -1 over 4 f of 2x minus 1. Okay, moving on to the next one, we have y is equal to f of 3x minus 6 minus 2. Very first thing we need to do before we look at a, b, h, and k is we actually need to factor the middle bracket. Okay, so this is actually going to become y is equal to f of 3x minus 2. Okay, minus 2. Okay, so now we can look at a, b, h, and k. So a is going to be 1. Okay, b is going to be, well, b is 3, right? So this is going to be a stretch by a factor of 1/3, right? So it's the opposite. We do have an h this time, so there will be a horizontal shift. So it's going to be 2. So we're going to move 2 to the right. Okay. And then the last one is a k. So that means k is -2. So we will move down 2. Okay. So the mapping notation and how it's going to look. Okay. So what we're going to do. Oh, let's get our original function here. Let's get our original function's values. Okay. This you can do on your own, but I'll just do it really quick. Okay, so these are now the points there. 3 and 9, 6 and 6, and 9 and 9. Okay, and how the mapping notation is going to look is we will stretch by a factor of 1 over 3 for our x values. So this is going to be x over 3, and then we're going to move it to the right 2. Okay, so those are our x values, and then our y values we are going to move down 2. Okay, so instead of it being at 3, we're going to go 3 divided by 3, which is 1. 1 plus 2 is going to be, well, oddly enough, it's back at 3. So we have 3 and then y minus 2, so it's going to be 3 and 7. So 6 divided by 2 is 2, plus 2 is 4. Okay, so it's going to be 4 and 4. And then for the 9 and 9, 3 divided by 3 is 3, plus 2 is 5. So this is going to be 5 and 7 again. Okay, so it's going to look, so the points will be plotted just like this. And then we can go ahead and create the graph. And that's it. Okay, so this is y is equal to f of 3x minus 6 minus 2. Okay, moving on to the last one, we have y is equal to 1 over 3 multiplied by f of negative x minus 4. Okay, so again, before we start, let's actually factor out the middle. So this is now going to change so that it's y is equal to 1/3 f of negative 1, and then we have x plus 4. Okay, so our a is 1/3, right? So that means that we're going to have a stretch of 1 over 3. B is negative 1, which means all we'll have is a reflection of the y-axis. And then we have h being, should be negative 4. So we're going to shift 4 to the left, and nothing for k. So there's no vertical shift up or down. Okay, so what we'll do is we'll map out our original points. So we can do that real quick. Okay, we have now gone ahead and found the original points. Now let's find our mapping notation. So our mapping notation is going to be negative x minus 4. Okay, and then for our y values is going to be y over 3. So we're going to divide our y values by 3. Okay, so instead of it being at 2 and negative 6, it's going to be at negative 6 and negative 2. Instead of it being at 4 and negative 9, it's going to be at negative 8 and negative 3. And then instead of it being at 6 and negative 6, it's going to be at negative 10 and negative 2. Okay, so let's go ahead and let's plot those points out. Okay, so now that we've gone ahead and plot those points, we can now graph it. So it's going to look something like this. All right. So there you have it. There is this particular graph of y is equal to 1 over 3 f of negative x minus 4. And we've gone ahead and mapped out what each of those are. So a, b, h, and k. And with the mapping notation, made it very easy for us to follow. But yeah, that is how you would do combining transformations. Moving on to absolute values. Okay, so again, graphing an absolute value, we did this in the first lesson. Okay, so a regular function, your linear function, will have a graph that looks like this. Obviously, your line will be a lot more straighter than mine. Okay, the absolute value of x. Okay, so that's going to change all your y values so that they're all positive. So it's going to come down like this, hit the x-axis, and bounce back up. So it's going to look like a linear function, but all the values below the x-axis will actually become positive values. Okay, so all the values below the x-axis will become positive values. Okay, so graphs of absolute value functions are created by reflecting any portion of the original graph below the x-axis to above the x-axis, and that's what we did. Right, any parts that are below, you're going to reflect as soon as it hits the x-axis, bounces and goes back in the positive direction. So the steps to graphing: sketch the original function found inside the absolute value. 2, reflect any portion of the graph lying below the x-axis to above the x-axis. So essentially, you're making all those y values positive. Okay, so instead of those y values being negative, just make them their positive values. And then anything outside the absolute value, you do last. Okay, so let's look at the first one. We have y is equal to the absolute value of x squared minus 4. So again, the first step would be creating the original graph. So y is equal to x squared minus 4. So essentially, this is an... so I'm going to do this in red. I'm going to do the y is equal to x squared minus 4 in red. So essentially what this is it's your regular quadratic function, except your vertex has been moved down 4. So instead of it being at 0, 0, it's now at 0, 4. Okay? And then it follows the same pattern like so. Okay? So it's going to come down, right? Same kind of graph as you've made previously. Okay. So that is your y is equal to x squared. But your absolute value of x squared minus 4. So again, it says reflect any portion of the graph lying below the x-axis to above the x-axis. So everything that's below will be reflected up. So you're going to have the same x-intercepts, but all these values, these y values that are below will actually come up. So instead of it being at 0 and negative 4, it's going to be at 0 and 4. Instead of it being at negative 1, negative 3, it's going to be at negative 1 and 3 and 1 and 3. It's going to follow the exact same pattern though. So the only difference, so it's going to come down, touch this point, but it's going to reflect up, come down, bounce off, and then continue. Kind of cool, but that is how this one will look. So again, the steps to graphing absolute values, again, is to look at the original one. So that's the one that's inside the absolute value. Graph that first. Anything below the x-axis, you just reflect. And then if you have anything that's outside the absolute value, you do that one last. Okay, so let's do an example of that. Okay, so here we have x squared minus 1 plus 3. Okay, so what we'll do is we'll do this in steps. Okay, so I'll say, let's do y is equal to x squared minus 1. Okay, so x squared minus 1 looks like this. So here's your x squared minus 1. So I graphed this one first. Okay, so that because the next one what we're going to do is we're going to put the absolute value around it. Okay, so that means anything below the x-axis will be reflected up. So your graph will follow the exact same pattern, except it's going to come up. So it kind of creates a little W. Okay, the last part we're going to do is we're going to add in the plus 3. And the plus 3 tells us, well, we're going to move it up 3, right? That's essentially what it's telling us. Okay, so this is going to be the absolute value of x squared minus 1, and then we're going to add 3. So this tells us we're going to move up 3. This is like your k value, right? This is your f of x, right? This is your f. That's your f of x. And now this is f of x, and then you're going to add 3. So that's what we're going to do. We're going to move all these values up by 3. So this will be 1, 2, 3. So your graph will look like this. Okay. There you go. That's how you would do. That's how you would graph this one. Y is equal to the absolute value of x squared minus 1 plus 3. Again, following the steps. Graph the first one, like the original function with the absolute value, or without the absolute value. Then put all your y values that were negative, reflect them on the x-axis. Okay, so just make all your y values positive. Okay, and then apply any transformations after that. So if you were to double it, then you would go ahead and double it, right? If you were to add 3, and so on. Well, that is it for today's lesson on combining transformations. I hope you enjoy it. Remember, when it comes to math, keep calm and show your work.